If you look at the orbits of the planets in the solar system, not like that, to scale, you'll see that something looks off. There's this huge gap between Mars and Jupiter, almost as if something is missing. No, it's not a fulfilling life, but rather a planet. Why isn't there a planet orbiting here? Well, according to some big-brain science dudes, there may once have been. In a paper detailing their hypothesis, they call this hypothetical planet Planet 5.
How original.
As in Roman numeral 5, as it would have been the fifth terrestrial planet. According to the hypothesis, it would have been about a quarter of the mass of Mars, or 0.025 Earth masses, and formed between Mars and the asteroid belt at 1.9 astronomical units. It would have stayed here until the other terrestrial planets began to perturb its orbit.
Why you bullying me?
Meaning that their respective gravitational poles slowly began to pull it off course. Eventually, it got pissed off so much that it decided to commit die by crashing into the sun to Mars.
What are you doing?
I'm adding this
Now
to
are you a prostitute?
I'm adding this
No!
to your cash.
No!
After around 600 million years. Alternatively, it may have just had enough of everyone's crap and left the solar system completely. In its final days, it would have gone on a rampage, scattering asteroids from the asteroid belt all over the inner solar system, and thus causing what's known as the Late Heavy Bombardment, which is essentially a period of extremely frequent asteroid impacts in the inner solar system between 4.1 and 3.8 billion years ago. That is believed to have occurred because many of the rock samples gathered from the moon during the Apollo missions were radiometrically aged to about 3.8 billion years. 3.8 billion years is much younger than the age of the moon, which suggests that the surface of the moon was molten up until this point. In fact, the whole reason that this hypothesis exists is that it, along with many other proposed explanations, tries to explain why this event even occurred in the first place. In order to test their hypothesis like true science dudes, Chamber and Lassauer ran 36 different simulations, adjusting different parameters between each one, with Planet 5 ranging from small to slightly less small to about Mars-sized. Here's a graph showing the orbital evolution in one of these simulations, with the different colored lines representing Venus, Earth, Mars, and Planet 5 respectively. As you can see, things start off relatively stable, but eventually Planet 5's orbit becomes highly unstable, dangerously swooping through the inner solar system until it is finally lost after about 600 million years. At the same time, this graph, showing the number of asteroids on Earth crossing orbits, shows that the asteroid impact rate would have increased while the planet was in its unstable phase. Looks pretty good, right? Well, this simulation is a bit of an exception as, of all the simulations run, only about a third of them were considered to be successful in that the planet either crashed into the sun or was ejected in the first billion years, and increased the impact rate on the other terrestrial planets, producing a system like the one we see today. However, the other two-thirds of simulations are considered unsuccessful, as the solar system ends up in such a way that is different from what we see today, such as Planet 5 surviving or the other terrestrial planets colliding. Upon later review, though, the hypothesis was considered to be unlikely, as it revealed that such a planet probably wouldn't have been able to scatter enough of the asteroid belt to reduce it to its present density, and most of these simulations were unsuccessful anyways, so it isn't considered very plausible by most scientists. However, it's still kind of fun to imagine that there was an entire planet out there that just ceased to exist. Wait, there's also Thea. You know what, never mind. Thanks for watching.